Hi everyone! In today's video, we are going to be solving this equation right here. It's a pretty simple problem, so if you want to give it a shot, you can pause the video here. Alright, so I have rewritten the problem for us here, and now some of you might have noticed a certain logarithmic identity that we need to use to solve this problem to make it really simple. I'll go ahead and write that identity if you do not know it. It basically states that log base a of b times log base b of c. When you multiply these two, it basically equals to log base a of c. And in this case, b, these two are obviously the same number. So up here, we can recognize that we can actually apply this identity with, in this case, 3 being the b in this equation. So let's go ahead and apply this identity to our first two terms and just see where we get from there. If we multiply these terms together, that'll give us log base 2 of 4. I've just applied the identity just now. And now it's very good to realize that if we were to multiply this next term, like we're going one by one to the right, we can apply this identity again because we have 4 in the base up here and we have 4 over here. So we can apply the identity. If we were to multiply this by that next term, log base 4 of 5, that'll just be log base 2 of 5. Now you might be noticing something here. Every time we multiply the next term to the right, we always keep the base. It's still log base 2, that is not changing. It's only the actual argument that's changing. But just in case we're skeptical that it will stay, let's try the next term. The next term that we have to multiply is not written up there, but we know that our sequence is log base n of n plus 1. So we know that the next term, we have our original log base 2 of 5, which is the product of these first three. The next one will be log base 5 of 6. And again, we can apply the same identity to get log base 2 of 6. So now we've noticed that every time we multiply the next term, our log base 2 is always kept. So now that we know that, we can just generalize for log base n of n plus 1. Let's say we multiplied everything all the way up to here. Well, based off of our observation earlier, we should have log base 2, right? And inside here, we're going to have n plus 1. And this all equals 210. So now that we have this, we can easily solve this problem because 2 to the 10 equals n plus 1. This is just what a logarithm is. And to the 10th is 1024. So this will equal to n plus 1. So therefore, n equals to 1023. As you can see, using this really useful identity here, we can solve this problem pretty easily. Thank you so much for watching. Please like, share, and subscribe.